All right, so this is the final set of videos for Unit 2, and we're going to look at one important theorem called the intermediate value theorem. All right, and then we're also going to do some unit circle review, all right, because we're only have kind of one extra thing to learn here, and then we're also going to just review some trig. All right, so first let's look at the intermediate value theorem. So there's a couple of important things to recognize is that f of x is going to be continuous on the interval AB. All right, so again, a couple of important things is that it's continuous. All right, so that's the first piece. And the second piece is on a closed interval AB, so the endpoints actually make sense. And then what is the setup? All right, Z is some number between the outputs at A and B. So here's the output at A, here's the output at B, and Z is some value in the middle. What the intermediate value theorem says is there has to be some x value C, so C is right here, that when I plug that into my function, I get Z. All right, so you can see, all right, this function is continuous. I don't have to lift up my pencil to draw the line between these two places. I don't know why it's not letting me draw. All right, there we go. So I don't have to lift up my pencil at all to draw the line between these two places. That means that if I pick any of these outputs in this region, between those two outputs, I have to hit them. So I could pick this value here, and you can see there has to be an input that got me there. I could pick this other value here, and there's going to be an input that got me there. All right, so this is what the intermediate value theorem says. If I have this continuous function, again, it's really important, that's why we're talking about this in the continuity unit. All right, continuous function, I hit every single y value between the y value at A and the y value at B. All right, so what are some ways that this theorem are going to get used? All right, one is to show that there's going to be a 0 without using a calculator. So how could we do this? Well, first of all, x minus cosine x is going to be continuous because this is just a polynomial and this is a trig function, so there's no weird stuff happening. So it's continuous, so that fits that part of the intermediate value theorem. All right, what I could do is I could say plug in, I'm going to plug in 0 into the function, so it's going to be 0 minus cosine of 0. Cosine of 0, we're actually going to do this review after this video, is 1, so I get negative 1. So I plug in 0 into this function and I get 0. Another thing I do is say plug in pi. So when I plug in pi, I'm going to get pi minus cosine of pi. Cosine of pi is negative 1, so it's going to be negative 1, which is pi plus 1. Again, pi is about 3.14, so that's about 4.14. All right, so if we think about what this means, at 0, I'm going to have, let's make a graph. At 0, I'm down here at negative 1. At pi, I'm up here at 4.14. All right, so I have these two dots that I know 100% are on my graph. And this is a continuous function. I have to get from the red dot to the green dot without lifting up my pen, so I have no idea what it looks like. Right, but I know at some point I have to make it up to the green dot. And what happens, there's no possible way for me to get from red to green without crossing the x-axis at some point. All right, so this proves that there's at least one 0. All right, because at some point, if I had to go from a negative to a positive with a continuous function, I have to hit 0 at some point because 0 is between the negatives and the positives. All right, so this is one way the intermediate value theorem is used a lot. All right, if you know you have a negative and you know you have a positive, somewhere in the middle you have 0. All right, one thing you have to be careful with is let's consider this function. All right, at 0 we have 2. And at 2 you have 3. All right. Can we conclude that f has no zeros between 0 and 2? So what you might think is, well, I just connect these dots, and that never crosses the x-axis, so this doesn't have any zeros. But the thing with the intermediate value theorem, it only says that I have to hit everything between 2 and 3. It doesn't say I can't hit the stuff outside of it. So instead of this green graph, I could have a graph that looks like this. And it could look like this yellow graph, and you see this yellow graph goes down and it hits the x-axis 4 times. And it doesn't make the intermediate value theorem wrong, because I still do hit all the values in between 2 and 3. I just hit some stuff outside of it as well. So just know when you're applying the intermediate value theorem, it only means you definitely hit the stuff in between. It doesn't mean you don't hit the stuff that's not in between. All right, so just knowing you have 2 positive numbers is not enough to conclude that you don't have any zeros. And this is another one of a popular type of problems related to the intermediate value theorem on the AP test. All right. They'll give you this table and say what's the fewest number of zeros that you can have. And I didn't write it in here, but it should be part of this problem, is that f is continuous. We have to know that f is continuous, because without that, we can't use the intermediate value theorem. But this pretty much goes back to our other example, is that whenever you go from a negative to a positive, somewhere in the middle, you have to hit 0. So when our function values go from a negative to a positive, this has to be a 0 somewhere between -2 and 5. All right, when I go from a positive to a negative, well, that's the same idea. That's also going to be another 0 has to happen between there. And lastly, if we go from -1 to 3, that's a negative to a positive. That's going to be another 0 that has to happen in that region. All right, so for the answer, this one, you just select the multiple choice answer. That's 3. So it's pretty much every single time you go from negative to positive or positive to negative, at some point in the middle, you have to cross 0. All right, so that's going to give you a 0 using the intermediate value theorem. All right, so that's technically the end of Unit 2. All right, we talked about continuity and asymptotes and the intermediate value theorem. All right, so that's all that's going to be on the Unit 2 test.